In Chapter 4, on slide 26, we're looking at single exponential smoothing. There's two formulas for single exponential smoothing. And the first one looks at a smooth forecast of time period plus 1 is equal to an alpha times the actual time period, and your alpha is a constant here, plus 1 minus that constant times the smooth forecast for the time period. And I'm going to go back and we're going to look at this here a little bit differently in just a minute to get at a better understanding of the formulas. But the second formula, which is actually a manipulation of the first, and it is actually found in your book, and of course I didn't write down the page, is my preferred formula. And this formula is the smooth forecast for a time period plus 1, or your next time period, is equal to your smooth forecast for the time period plus that constant, or the alpha, times the actual for a time period minus a smooth forecast for the time period. This is my preferred formula because I find it easier to use and I can actually work through it better. I like the way it works through things. So I prefer this formula. So if we go and take a look at our single exponential smoothing problem, which is slide 26, we have a demand for a certain model of snowboard during the past 5 months is shown below, November through March, and it's respectable of actual demands. Compute the forecasted demand for each month from November through March using a single exponential smoothing with an alpha of 0.02. Assume that the forecast for November was 212. You need to have a starting forecast here. So we're going to assume that our November forecast was 212. What we're going to look is, how do we get a smooth forecast for December if we know what November's actual was, or how can we do this for next year, looking at next year's December, etc. So what I want to take a look at here is using this formula. I'm going to rewrite it on the next page and go through what we're going to be taking a look at. So while it says that the smooth forecast for a time period plus 1 is equal to the smooth forecast for the time period plus our constant multiplied by the actual for a time period minus the smooth forecast for a time period. What does this mean? Well, we have a forecast for November and we want to find, to begin with, a smooth forecast for December, which is our next time period. So we're going to take a look at the smooth forecast for November plus our constant, which is 0.02, times the actual forecast for November minus the smooth forecast for November. That's what we're looking at. And what we're going to do is use the numbers that we have here in this problem. So we want to find our smooth forecast for December. What was our smooth forecast for November? It was given at 212. We want to add to that our alpha, our constant, which is 2, times what was November's actual forecast, 196 minus the smooth forecast for November. So our formula for this problem ends up being 212 plus 0.02 times the quantity 196 minus 212. Now, why do I like this so much? Because it's easy to do on the calculator. I'm going to work it step by step first, and then I'm going to tell you how you're going to punch it into your calculator that this makes it easy. Especially if you don't have a calculator with all the little parentheses and everything on it. I buy the cheap calculators, folks. They don't have parentheses. As long as I have a square root, I'm good. So we look at 212 plus 0.02. 196 minus 212 is a negative 16. I'm going to take my 212. My 0.02 times a negative 16 is a negative 0.32. My 212 minus a 0.32 is 211.68. If I wanted to do this quickly on my calculator, I can take 196 minus 212, multiply that by 0.02, and add 212. So I literally am working piecemeal backwards in order to do this problem easily on the calculator. And I think that's really why I like this formula better. Now, I have my smooth forecast for December being 211.68. So I can go back to my forecasting chart here, and on December say that it was 211.68. And I'm taking this out to 2 decimal points for the simple reason that my exponential smoothing was at 2 decimal. My alpha was at 2 decimal points. Depending on what you produce will depend on how many decimal points you go out. If you are producing planks of wood, you probably, you can't make a percentage of a point. So you might just round up or round down, depending if it's 0.5 above or below, to get that the number of planks of wood forecasted that you're going to be selling, needing, whatever. If you're working with medication and it's something for neonatal, you might go out 10, 15 decimal places. So depending on what you're producing will depend on how many decimal places you have to go out. So we're looking here for exponential, with the exponential smoothing, and we found December. So we now can go back and look at January. What we're looking at, we have now our smooth forecast for December. We want to find our smooth forecast for January. How are we going to do that? January is our next time period. We're going to take the smooth forecast from December plus our alpha times the actual forecast from December minus the smooth forecast from December. And we're just going to plug and play is what I call it. Just plug in the numbers that we have. Well, if we go back one sheet, which, oh good, it's back up to regular size again. If we go back one sheet, we found that our smooth forecast for December was 211.68. So I know that I'm going to have 211.68 there. I'm just plugging that into the number plus 0.02. My actual for December now, because everything on this formula is from the same time period, was 268 minus that forecasted, 211.68. I can now plug into my calculator 268 minus 211.68 times 0.02 plus 211.68, and I should get 212.81. So that's my smooth forecast for January. I'm going to take that and plug it into my smooth forecast for February. My smooth forecast for February is the smooth forecast from January, 212.81 plus my alpha times the actual forecast for January, which if you go back to your PowerPoint slide was 315. Subtracting from that the smooth forecast from January, 212.81. So if I take this and I plug it into my calculator, 315 minus 212.81 times 0.02 plus 212.81, I get my smooth forecast for February, which should be 214.85. So I now have my smooth forecast for February. I can go on and find the smooth forecast for March by plugging in the numbers for February. So I'm going to just move this because of space to the next page and find my smooth forecast for March. And that's going to be my smooth forecast from February, 214.85 plus my alpha, 0.02 times the actual from February. That back on our slide was 299. Subtract from that our smooth forecast from February, which was 214.85. Again, if I take this and work it backwards on my calculator, 299 minus 214.85 multiplied by 0.02 plus 214.85, I end up with my smooth forecast for March, which is 216.53. Now, it doesn't ask you to do this on here, but you can actually find the smooth forecast for April, because we have the information we need to find that out. Where do we get it from? We start with our smooth forecast from March, 216.53. Add to that our alpha times the quantity, the actual forecast from March, which if you go back onto the slide was 101. Subtract from that the smooth forecast for March, which was 216.53. Again, if you work this backwards on your calculator, 101 minus 216.53 multiplied by 0.02, our alpha, plus the smooth forecast from March, 216.53, we end up with 214.28, I believe, as our smooth forecast for April. Now, because we don't have the actual demand in April, I can't go any further at this point. I need to stop here. But this is how you do single exponential smoothing.